Welcome friends. Today we are going to discuss about ECBC code 2017. What is ECBC? It is Energy Conservation in Buildings Code. It is notified by Government of India, Ministry of Power. We all know energy conservation is very important. So this is the title of the project, Energy Conservation Building Code 2017. 2017 simplifies in which year it is notified. It is a code, means must be followed by all the agencies. It is notified by the government and Ministry of Power. This is the code book. So it will be available on their website free of cost, no need to buy. It is done by with the help from Bureau of Energy Efficiency, the regulatory body through which government controls all the energy conservation measures in India. The disclaimer. So even though care was taken to present the facts, but some last minute changes and change in government notifications, IARE is not responsible for the fallout. What is the importance of ECBC code implementation? See, there is a great urbanization shift going on. A lot of people are migrating in search of livelihood to the cities. It cannot be largely not preventable. So the residence houses and other dwellings in the city is growing at a very high speed. For example, in India, it is growing at 10% compared to world average, close to 5%. It is projected that by 2030, nearly 2/3 of buildings will be new, yet to be built as on today. Okay, and that approximately it is 1 billion meter square of new commercial buildings will be added by 2030 in India. So huge construction activity to accommodate all these people. You are aware of this 2-bedroom flats and all. So like that, many commercial buildings and residential and commercial buildings are going to be added to the landscape to house all these people who are migrating from villages to cities. So large scale buildings are being constructed. So the building, if it is not properly connected, can consume more energy. If it orientation and if it is made provision for natural lighting, it is made provision for ventilation, then it will consume less energy. Otherwise, heat load will go up and more air conditioning load and more lighting load. So government and many other bodies has committed to reduce their footprint with respect to energy by agreeing for the COP restrictions and other things. COP21 we are signatory to that. So it is very imperative that we should construct buildings in such a way they consume less energy. It is not only less burden on the users of that building, it also saves the environment. So buildings will going to consume roughly 30 to 35% of total energy produced in India. That is one forecast by 2030. As of today, the building sector is consuming about 25% of total all energy generated. Industry is consuming little more, maybe close to 27-28%. Industry is consuming total energy produced. Now, buildings are going to take over before 2030. Buildings are going to consume 30% of the energy produced, and industry may fall back to 25% or less. Okay, in a commercial building, what are the main energy consuming, energy gulping devices? Highest is chiller, that is related to air conditioning. In a building, air conditioning consumes nearly 38% of the electricity consumed. Then you could see lighting. Lighting is close to around 8 to 10%, and some pumping and other application. So large portion is air conditioning and ventilation. So it is projected that building sector is going to consume 30 to 35% energy by year 2030, and commercial sector in that is 8%, of the total. And residential sector, human dwellings will be consuming 25% of it. This 25 plus 8 makes it to 33%. So, in other words, buildings, both residential and commercial put together, is going to consume whopping one third of the LCT produced in India by year 2030. So, there shall be a great effort to conserve energy and save that it is not inefficiently run. So ECBC compliance aims at saving this energy 40 to 60% of the LCT. If the building was made to follow ECBC rules, this has a potential to save 40 to 60% of the LCT. So nationwide mandatory compliance, if everybody follows the ECBC by 2030, we can save whopping 1.7 billion kilowatt hours. So the CCPC code helpful in planners, building regulators, the municipal town planning where they approve the building construction. So they will be first trained and they will ensure that all new buildings coming up are compliant with this code, so that we can save a lot of energy in future. What are the other benefits of following ECBC? Lower HVAC loads, reduce energy consumption and operation cost, lesser addition of power generation. Suppose we don't do this, what happens is we have to generate more power. In order to generate more power, we have to dig more coal, or we have to use more fossil fuel, or we have to install much more quantity of solar panels to meet this LCD demand. Suppose we reduce the consumption itself, then that much saving can also be made without putting an additional investment. So this consists of giving a good ventilation, natural lighting to the extent possible, daytime lighting use. For example, college buildings, most of them they are operate only daytime. So the building was properly designed. There is no need to have a artificial lighting. So it should be wisely designed in such a way that the natural lighting available in the daytime is good enough for the operation of the class. Similarly, ventilation, we provide good windows and class ventilation. So no need to have so much AC loads. For all this to make, we have to use good materials, good building materials like glass, which transmits less heat, and insulation, which stops heat entering into the building, and very efficient air conditioning system, such things. So at present, what are all the other building energies other than ECBC? There is one standard called ENS Samhita, Econivas Samhita, that is meant for residential building, as ECBC is for commercial buildings, Econivas Samhita is for residential buildings. There is parallelly other IGBC standards and green rating for habitat. So many other standards were there, but this particular class is going to discuss on ECBC. And there is one more provision, US lead rating. So there are all people should be aware that there are 4-5 different methods of making out whether the building is energy efficient or not. Okay. ECBC is a code, it's a mandatory code. So its definition goes like this: if the building complex, commercial complex, like cinema hall or a mall or a hospital or a hotel or educational institute, if the connected load of 500 kilowatt, okay, 500 kilowatt or more, 500 kilowatt or more connected load, or there is another class, 600 kVA of demand, contract demand. See, what is connected load is maximum limit is 500 kilowatt more than connected load is there, then you have to follow the ECBC code. Or if your contract demand is more than 600 kVA, then also you have to comply with the ECBC. So what kind of buildings they are? Probably they are shopping malls which is having consumption of more than 500 kilowatts. School, college, hospital, airport, bus terminus. So different kinds of buildings probably are commercial buildings and consume more than 500 kilowatt. So the code will become mandatory once government notifies it, either by state or central government. Many states already notified this. For example, Andhra Pradesh government already notified this. Telangana government is going to notify maybe by year end. Are there any exemptions for this code where you need not follow this code? Yes, there are exemptions. Suppose there is a building, the entire city for that building is produced using solar panels above the building, not using any fossil fuel or electricity for this building, then they are exempt, no need to follow. Equipment and portion of the building system that use energy primarily for manufacturing purposes. Suppose there is a building inside the factory, their energy is used for produce things, not for its own consumption. Energy is for cutting the metal or building the metal. That kind of consumption will not come under ECBC. So, is there any categories of building efficiency? Because more efficient, less efficient, there should be some distinction. So, three level of categories of buildings were identified for measuring energy efficiency levels. The simple one, minimum level of compliance, is ECBC building. If a building meets minimum requirements of this code, is called ECBC compliant. If it is little more, it meets not only ECBC, it saves much more higher than the what minimum requirement of ECBC, then it is called ECBC plus building. It is great to have a ECBC building plus category. It is a pride in the society, and also government may in future give incentives for such buildings. Then last category, that is most important, most highest efficiency category, super energy conservation building code building. That is saves much more than the ECBC plus building. So your building can be classified into one of these three categories, either it's a minimum compliant ECBC or slightly better ECBC plus or super ECBC. So if everybody, then it will try to get a super ECBC tag for their building, then it is a pride. What is the expected benefit? Cost benefits, I mean, for taking the compliance. If your building is compliant with ECBC, you can save something like 23% of the 20 to 25% of your LCT. If you construct a building as ECBC plus category, then you are likely to save 35% of LCT bills in future. But ultimate, if you build your building, commercial building, to meet super ECBC category, you will save open 50% of your LCT bills. That is a very super efficient building. Now, as per the government is concerned, at least you should meet ECBC compliant. That is mandatory. Everybody, all commercial buildings above 500 kilowatt must meet ECBC compliance, which is mandatory. Other ECBC plus and super ECBC plus are voluntary in nature, but it is beneficial to you. So, in 10 years of implementation, suppose we implement in 10 years, we will be able to save 15 gigawatt peak demand reduction. Over 250 metric tons of CO2 GHG abatement means by saving the LCT, you are reducing the use of fossil fuels, that is equivalent of reducing the CO2 emissions and like planting more trees. So in terms of cost, you are going to save something like 35,000 crores by implementing this. So that's why the government is giving a lot of importance to this. Purpose. What is the purpose of this one? Government has enacted a Act, Energy Conservation Act 2001, in which there is a chapter, section 14P indicates that they are going to notify the energy efficiency in the buildings. This code is to meet such requirements. Okay. Suppose new buildings has to comply with the ECBC. Everybody understood that if I have to build a new building, commercial building, it must meet ECBC condition, ECBC compliant. Otherwise, even permission will not be given to build such a building. The municipal authorities who gives the building permission will first ask, is this design what you made for this building is ECBC compliant or not? If it is not ECBC compliant, permission is not granted to construct this building. So, but what happens to, I am not constructing a new building, I am only making a new floor, I am only modifying the existing building. Then whether code is applicable? Yes, it is applicable in parts, means the modified part of the building alone shall meet this requirement, or the modified part along with the main part can also meet the compliance. And all the new equipment purchased shall meet Bureau of Energy Efficiency BE star rated products only you should buy. Generally, how the efficiency of a building is determined? It is determined by building consists of walls and roof. The building envelope is called roof plus walls and the windows also. The building actually it is exposed to sun. Lot of heat ingress from the roof. That is 30% of the heat in any building comes through the roof. And some 20% comes to the walls. All not 4 walls were lit simultaneously. Maybe east side wall will be lit in the morning, east facing wall. West side wall may be lit in the afternoon, and the south wall may be lit most of the time. North wall may not be lit that much. But some amount of heat ingress to this wall will be there. Much more worse is there is a windows, glass windows with a openable doors. If you close that window, the lot of heat can pass through the glass. Glass is a good conductor of heat. It will pass the heat into the building. So a lot of discomfort people will be feeling inside. So they will switch on the AC. So a lot of energy demand. So you have to have only minimum glass area so that inside people are not exposed to undue heat. So have minimum number of openable glass windows. Only that should be required for meeting the lighting needs. Two, where else the energy is consumed? The energy is consumed, the building is not properly ventilated. All the 24 hours you have to run AC, you have to run ventilation. So all these motors will be running, a lot of energy is wasted. You have to see that building is constructed in such a way natural ventilation will reduce the heat load inside the building. Or even if air conditioning is to be only, it should be used in summer and only in few select areas. So rest of the building is comfortable for people. You should design the building such a way. Okay. Then where else lighting is consumed? Energy is consumed. The building is not properly provided with the natural lighting. Even all the rooms, daytime itself, you have to put on the lights. Kitchen, nothing is visible. Hall, nothing is visible. Put on the lights full day also. Then it is add to cost of energy and energy waste in the form of lighting during daytime also. So you have to see that some natural lighting is coming. At least daytime and need not have to use artificial lighting. And similarly, lighting is to be provided as light, but if I provide 100 watts instead of 20 watts, what is required to really lit the corridor, then I am wasting a lot of electricity and lighting which is not useful. 20 watts is sufficient to lit the corridor to see who is coming, who is going. But if instead of 20 watts, if I use 100 watts lights in that corridor, I am wasting a lot of energy. To design correct size. Then outside the building, there are certain equipment like transformers. If you use inefficient transformers, lot of energy is wasted. You have to use more efficient transformers, more efficient motors for pumping, lift. And you have to always see that power factors are completely within 0.95 to 1. The power factor is very less, then your energy is wasted. So it should power factor close to unity always. There shall be automatic power factor corrections to be done. Then if you put long cables with small cables, there will be a lot of losses. So cable shall be sized adequately, and long distance we should not run the cables. As far as possible, you should have closer application and the device, so that less length of cable and less loss of uh, power through the cabling. There's other provisions in the act which says you have to give provision for renewable power generation future. Means in the rooftop you have to provide some space for at least some portion of the LCT and the hot water to be generated from rooftop. So what the code focuses: natural ventilation, daylighting, and heat gain or loss into the building. The heat gain or loss into the building is through two means, either roof or to the walls. Walls may includes both windows and the plain wall also. So how do you know a building is constructed well or not with respect to heat transmitters? We all know if the building wall is thick, less heat will flow inside. The building wall is too thin, then more heat will flow. So building wall shall be having good thickness. But thickness increases cost, so you have to have optimum. Or use the better material which is least conductive of heat. Use the material thickness, you maintain same maybe 9 inches or whatever, but use some layers of insulation or a kind of a material which transmits less heat. So the property of that material which transmits responsible for transmission of heat is called U factor. So what clauses of the code to be fulfilled? There are many clauses in the standard. The clause number 4 to 7 of the standard is a must because they are mandatory requirements. In addition, you have to meet certain requirements of the clauses 4 to 7, some part of it. Depends on whether you are going for Ecbc or Ecbc plus or super Ecbc. And clause 9 says what are the alternative means of fulfillment. As I explained, what systems in a building are to be evaluated. Building envelope is the main responsible which gives heat into the building. So we have to examine how the building envelope is constructed. What is the wall thickness? What is the material of the wall? Then what are the systems inside the building like AC, heating, ventilation, air conditioning? How efficient they are. If they are not efficient, then a lot of energy is consumed. Then lighting. Whether lighting is adequate or not, whether lighting is properly switched on timely, or even the people are not there, lights are simply on. There shall not be any wastage. Suppose there is a conference hall, people after leaving the conference hall, people forgot to switch off the lights. Then there shall be a sensor which sees there is no people movement inside the conference hall and switch off these lights. Then it will save. So motion sensors in the conference hall is one best example of saving the lighting energy. This standard does not apply to the plug loads. Means suppose a motor car is there that is to be charged using this. So that charging current, the LCD consumption because of this will not be counted when the building is made. So building envelope, mechanical systems, ventilation, these are the main things. Outside you have transformers and high efficiency motors. What is the reference standard for this? The Ecbc code 2017 is derived from a national building code, which is a master document which is released in 2016. It's called NBC, National Building Code. From that, this is derived. This also taken help from the standards and labeling program of Bureau of Energy Efficiency and some other standards. What type of commercial buildings are there? We told commercial buildings. This code is applicable to commercial buildings. What are the commercial buildings? The first kind of commercial building is the hotels, where you can stay for a night. So there are how many bed hotel it is. Hotels is a commercial building. Then hospital. The hospital not only takes care of daycare like outpatients, there can be some admission bed, some 100-bedded hospital, for example. So hospitals with beds is a big consumer of electricity. So hospital, hotels, hospital, Then there can be a bus terminus or airport. Okay, there are a prayer hall, a church. Those are the buildings, assembly buildings. They are called. They are also called commercial buildings. Then there could be office buildings, like Google office, or some government office, or some data center, or some BOP. All these buildings with lot of people inside and lot of data storage inside consumes lot of electricity, more than 500 kilowatt. So those buildings, either classified as a hotel or a hospital or a assembly building or a office, and there are schools, colleges. There are many people and lot of electricity can be consumed in these buildings. Schools, colleges, universities, also commercial building. Then the most consumption of the all could be, there can be shopping malls where a lot of lighting and a lot of air conditioning. So shopping malls is the one of the energy guzzlers. So shopping malls also comes under the commercial building. So these primarily the six categories of the buildings are made to comply with the ECBC code. Now the heat ingress into the building is not same in all the buildings constructed all across India. In some places, there is a heat conditions are different, humid conditions are different, the sun direction is different. So, while approving the building plan, they will also look for where this building is to be located. If it is going to be located in a cold place like Ooty, then we should not have that much insulation. We should have rather insulation for not losing the building heat during night. We should retain the heat, whatever gained, lot of heat to be gained during day and keep it for night. So cold place has a different story. For other dry places, we should see that not much heat is ingressed into the building, so their roof insulation also is stable. So this is also taken care that which climatic zone of India this building falls. So that is important. So for this purpose of ECBC, India was subdivided into 5 different temperature zones, climatic zones. So hot and dry, like Rajasthan and all, hot and dry. Then you have a cold. Cold means hill stations, Ooty, and some place in Meghalaya or in Kashmir. They are all cold places. Then there is a temperate climate, means it is not very hot, it's moderate, and but it will have the moderate humidity. So there are temperate climate is mostly comfortable. 10 months in a year is comfortable. Then there is a coastal line where most of the time it is humid and warm. So this kind of categories were there. So to know which part of the country this building is to be located, accordingly you have to apply the provisions of the code. So how to determine whether a building is compliant with the code or not? So for that, primarily you have to determine what is the EPA and EPA ratio. EPA is a ratio of what is the annual energy consumption total in kilowatt hours of the building divided by total built-up area, excluding of course the unconditioned basement and all need that be considered. But total built-up area where people reside, that area is the denominator. And what is the total energy consumption of the building in a year? So that is an index which shows how much energy you are going to consume per square foot of the area, how many kilowatts of energy, how many kilowatt hours of energy you are consumed per square foot of the area. That is the EPA ratio, which indirectly indicates how energy efficient is your building is. Lower the EPA, the better is the building. Then there is a APA ratio. You have to calculate this ratio for your building. So you have to calculate EPA of your building and EPA of a standard building where all the code requirements are met. Take that ratio. It should be less than 1. Then only the building is said to be compliant. So meeting EPA ratio can be just follow prescriptive provisions of the code which are listed in clause number 4.3, 5.3, 6.3. If you cannot do that, you can do that by alternate means. So building envelope trade-off method, which was described in clause number 4.3, that means in some part of the building you will not be able to meet code provision, but some other parts you meet or exceed the requirements. So the energy gain there can be offset against energy lost in a particular area of the building. So that is the building envelope trade-off method. Using that method also you can show compliance. Then there is third method, completely model entire building with respect to solar heat gain, use computer programs and calculate and show your energy building is energy efficient with respect to so many other factors, and its energy consumption overall is less than a standard building. Then also it meets the compliance. So one can choose what the compliance approach they approach. Simple approach is meet the provisions of the code, or completely model in a approved software and show to authorities that I have designed this building like this, which is meeting the total energy consumption per year is less than a standard building. That also is allowed. Yeah, the what are the sections this particular standard describes about the envelope is described in section 4.2, and the lighting is described in section 6.2, and the electrical and other provisions were described in 7.2. So the each section describes a particular aspect of the code provision. So you have to examine each code and fill the forms to satisfy the building regulatory authority that your building is compliant with the code. Then only permission will be given to construct that building in future. One of the major culprit in wasting heat is lot of buildings are constructed with more glass, which is more than required glass area. I could see in Hyderabad there is a ICIC Knowledge Park, full glass building. So lot of heat is in the cities, like a virtual cooker. Inside people will be roasted with lot of heat coming in. Lot of AC day and night you have to run. So it is not an energy efficient building, but it may be having a strict showcase value. In future, it is difficult to get permission for such kind of buildings. So heat transmission you should reduce into the building by providing insulation to the roof and insulation to the walls, and have windows not very big size, and provide some kind of a cross ventilation in the building, so that you need not have to switch on artificial fans and blowers for meeting the ventilation requirements. There is one U factor for the buildings. U factor is determined what is the heat transmittance per square foot of the exposed area of the sun in unit time. In a square feet area, some say 100 units of solar heat is falling on that. Suppose it transmits 30. So 30 by 100, 0.3 will be the U factor. So it is measured in watts, how much of energy ingressed per meter square per unit temperature degree difference. It is a measure that how much heat flow into the building, to the walls, roof and the glass. Higher the wall thickness, lesser is the heat flow. If the wall is considered of a 12 mm concrete, 12 mm brick, less heat will flow. If it is only considered 6 inches walls, more heat can flow. Similarly, not only thickness, the conductivity of the material. Suppose normal concrete versus aerated concrete. If the aerated concrete is used in place of normal concrete, less heat will flow, because aerated concrete will have a less U value. You have to wisely choose the building material so that U value will be less. The second factor what the code considers is solar heat gain factor, SHGC. The SHGC is a measure of how much heat is passing through a glass window, a area where interface with the window. Glass, as you know, is very good transparent for the lighting, and heat also will come. I want actually lighting to come in, not much heat. But glass also unfortunately transmit heat along with the light. So if the glass is thick, less heat will go in. If the glass is double glazed, less heat will go in. If the glass is made of a superior material, less heat will flow in. So the solar heat gain factor of the glass, we need to ask the manufacturer and ensure that it is having less Shgc value before you install, choose the particular glass to use in the building. Another aspect is WWR. It is window to wall ratio. You have to have minimum windows. Suppose all entire building more than 80%, if you make windows, a lot of heat naturally ingress into the building. We should have only whatever window that is required sufficient for ventilation, and natural light only should have. We should not have complete building with too many windows. So this code specifies what is the window to wall ratio that is prescribed. Area of the windows which is openable with glass and all that, and total area of the external walls, that ratio. It should be as minimum as possible. There is another factor called WFR. This factor provides window to floor area instead of wall area. This is probably used for gaining the ventilation aspect of it. So in each climatic zone, what is WFR is specified by the code. If you see cold climate, the minimum WFR is 8.33. For hot climate, for a composite climate, the ratio is slightly higher. More ventilation is required, that's why more windows are required. So let us see how much heat that is each component is giving. The roof is contributing roughly 25 to 30% of heat into the building. So if roof is made of good insulating materials, that much heat it will not go into the building. So roof tiles, roof insulation is a good measure, or roof made reflective paint is a good measure to reduce heat into the building. Second most important is the glazing. Glass, if it is too big a glass area or a bad quality of glass, then glass can as well contribute 25 to 35% heat into the building. The third most heat gainer into the building is walls. 15 to 25% heat into the building is coming from walls. Walls area is usually large, all the four sides. No? So all the four sides area, the sun will be lighting at least two sides simultaneously sometimes. So heat gain through the wall. Wall, if it is very thin, then a lot of heat can gain. If wall is not good insulating material, a lot of heat can come in. So walls will be constructed with thick or good insulating materials. Then there is another factor which is not generally considered ignored, but it is significant, is air leakage. The window, around the window there is a openable area, there is a gaps. Through that gaps, hot air can leak in. Even though building inside is cold, you will lose that cold air to outside in hot zones, and in cold zones you will lose the inside warmness to outside cold. So the windows shall be airtight. Air leakage shall be minimum through the windows. Once you want to close, no air should be passing through the gaps. Now, what is the specification for the daylighting? For business and educational buildings, for example, for IARE, is educational building. If you have to meet Ecbc compliance for the IARE buildings, we have three main buildings. We need to get at least 40% of the lighting from the natural light, not use artificial light, at least for 40% of the area. So then we are compliant with the Ecbc. But if you can achieve 50% of the lighting from the natural sources, only 50% artificial, you are likely to get Ecbc plus category. And if you get your building light from the natural sources, from sun, 60% of your lighting from the natural resources, only 40% is artificial lighting, then you are qualified for a super ECBC with respect to lighting. For a star hotel and healthcare, the ratios are different. 30%, even if you meet the natural light requirement, then it will be given because it may disturb their functioning. If too much sunlight is coming into the healthcare industry, patient may be feeling discomfort. Then you can say resort. Resort, you should get at least 45% of lighting from natural resources. Shopping complex, good concession is given. Shopping complex, mostly objects were displayed. The sales will happen because of the color and the beauty of the lighting, particularly jewelry stores and glass stores. The lighting play very good sales value. So, many different colors of lighting, and the lighting is a prime requirement for sales. So, since functional requirement is there, this code exempts. They say only 10% of your lighting can come from the natural resource. 90% you can use artificial lighting. For assembly building like church, so it is completely exempted. Whatever natural light comes or not coming, no problem. For airport, for bus stand, there is no problem. There is no ECBC code compliance with respect to lighting, exempted. For if you want to qualify not ECBC but super ECBC, then your education student shall get at least 60% of the lighting from the sun. Only 40% artificial lighting is to be allowed. So, if you combine all these factors, like what is the heat gain through the roof, what is the heat gain through the walls, what is the heat gain through the window, all this, if you can combine, there is one factor can be developed called RETV. So, RETV is a measure of what is the total heat gain. Let us see how heat is gained, transmitted from the roof. So there is a what is known as U factor. The U factor is dependent on what is the thickness of your roof. Normally, most of the buildings will have 4 to 6 inches of the slab thickness, mostly concrete. It is a conducting, so the U factor will be like close to 6. But if you insulate the roof with the tiles, insulating tiles and all, you can bring down the U value to 1.2. By applying a reflective paint on the roof, you can bring down the U value to 1.2 or less than 1.2. So, for your building to be compliant with ECBC, your roof U value should not exceed 1.2. Then what about walls? So, roof, what is the U value of roof? Different construction. If you only use RCC slab like 4 inches, that is 100 mm slab, your U value will be 3.6, which is not acceptable. You have to bring down to less than 1.2. Suppose you add to the concrete some kind of a waterproofing and some RCC, some insulation, some slab, some tiles, then you can bring down the value to 0.62, which is less than 1.2, which is acceptable. Suppose you further insulate with the expanded polystyrene, some kind of false ceiling, and some kind of aerated concrete, all that if you use, you can even bring down the value to 0.54. Lesser the U value, better is the building with respect to heat gain. So, less will be the AC load. So, for a wall, there are different values. So, 3.77, different constructions of the walls have different kind of U values. If you see glass will have very high value, 5 to 5.8 U value. Too much heat is coming to the glass. So, we should not have unnecessarily too much glass area into the building. Only what is required for giving a natural light, and what is required to open, how much area to required to open for ventilation, that much only shall be have the glass. Rest of the thing should have a wall. So the recommended value for a U value for a building for ECBC compliant could be less than 2. So the roof value for various climatic zones is given in the table. So school buildings, in a composite climate is 0.47. The roof value in a hot and dry climate like a Delhi, it should be less than 4.47. So like that table is there. For a hospitality sector means it is hotels. So hotels with an area of more than 10,000 meters square, we should have the roof view factor is less than 0.2, very stringent. So U factors and solar heat gain, all this together are various composite things were listed in this slide. U factor is in a composite climate is told 3, and the solar heat gain factor is 0.27, and so there is lighting should be allowed to come into the building, not the heat. So glass shall be such that your SHGC of the glass shall be low. Then we now control the how much heat is coming in the building. Next, how we should determine that the equipment that is used for cooling this building, the air conditioners, should be good quality. Good quality means energy efficient. So there shall be how to know any air conditioner efficient or not. So there shall be PE stars. PE has on the nameplate of this air conditioner, stars will be written. If it is 3-star, it is moderately efficient. If it is 5 stars, much more better efficient. So more number of stars, more will be the efficiency. The code says you should have minimum 3-star rating to buy and use that particular equipment inside the building to get a ECBC compliance. There is one factor called ER, energy efficiency of the air conditioner, which is 3.4 into COP. COP is nothing but is ratio of what is the amount of heat that is thrown out by the AC against what is the amount of energy it is consuming. It is a output to input ratio. So that is COP. It is known in air conditioning term COP. If you multiply COP with 3.412, you get ER. The ER, if is more than 10.5 is recommended. Let us see what is allowed as per the ECBC for lighting. See, lighting building has different sections. So just office building, then 9.5 watts per meter square. For each meter square of the building, we should not use lighting of more than 9.5 watts. Hospitals, 9.7 watts per meter square. The building is 1000 meter square, 1000 into 9.7. That is that many watts of lighting only should be allowed. Shopping malls, slightly more allowed because more lighting is required to demonstrate the items to be sold. The sales pitch is more in front of good lighting. So shopping malls, the lighting allowance is higher. For university schools like us college is 11.2 because reading is involved, small letters and all. So little more lighting is needed compared to an office building. Library, more intense reading because small letters, my fine print, you have to read in library. Good lighting is required. It is allowed up to 12.2. Then various other dining, restaurant, dormitory, fire station, warehouse. It is a kind of a stores. 7 is sufficient. So I will ask one question here. What do you think is the lighting level allowed for a corridor? Corridor does not require much lighting as where you reading like library. So corridors and all will have this value very less, maybe 2 or 3 watts only per meter square. So WWR, what is the value? Window to wall ratio is 40% maximum allowable. So in a building walls, total wall area may we should not have windows not more than 40%. And visual light transmittance of that glass minimum value shall be 0.27. The glass you are buying or installing in this building shall meet VLT requirement. And assembly U factor shall be overall the light gain consideration, SHGC consideration, and direct conductance U factor consideration. All this together shall be meeting the ECBC values. Suppose in some parts of the building you are not able to meet requirements. No worry, you have to model entire building, show some areas for meeting better than the minimum needed, but overall the building is consuming less energy only. Then you can show that and trade off. Trade off means exchange for some other thing. Then also you can get a certificate from ECBC compliance. That is also not possible. Trading off is not possible. You are meeting and not meeting certain parts. But the entire building, along with the AC, lighting, everything, you completely model in a computer softwares, which is approved softwares of BE, show that your annual energy consumption is less than the standard building. Then also you'll get ECBC compliance. That is a little expensive to do, but whole building performance that is normally done to prove compliance in many large commercial buildings. So I request who are undergone this videos, students to take this as a project. Probably this is a multidisciplinary group of civil, mechanical, and electrical, electronics, and maybe some AI people together form some groups, and they come forward to make a project and measure our building efficiencies of all the building number 1, 2, 3, and let us see where we stand with respect to ECBC compliance in future. Thank you for listening this patiently, understanding the new subject. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.